Welcome to the very short bonus video on resonance. Here is a molecule where the positive charge is distributed all over the molecule by resonance. To figure out which carbons share this positive charge, we have to find the resonance structures. But first, let's look at the structure we have right here. This is a good one. We know this because the positive charge, the carbocation, is on a tertiary carbon, one that is bonded to 3 other carbons. The more carbons this cationic carbon is bonded to, the more stable it's going to be. So right off the bat, we know that this carbon is going to have a substantial positive charge. I'm seeing another possible tertiary carbocation here. So let's see if we can use an electron movement arrow to turn this into a carbocation. So basically what that arrow does is it takes 2 electrons from one bond here and it moves them to here. And the resulting structure looks like this. So we know that this carbon here is going to be, have a high partial positive charge because here is a resonance structure where that carbon has a formal positive charge. And this is we know it's going to be highly partially positive because it's a tertiary carbon. But notice here how we created a positive charge by moving electrons away from that carbon. And we got rid of the positive charge here by moving electrons toward that carbon. But there are more carbons that share this positive charge. We can do the same electron movement arrow in the other direction, and we get this as the result of that movement arrow. And so we know that this carbon here is going to be partially positive because it has a formal positive charge in a resonance structure. And we can move the electrons one more time with this result. Here's our final resonance structure. So we found resonance structures where this carbon are positive, this carbon has a positive charge, this one, and this one. So those are our answers. And we know that these two are going to be a little more positive probably because they're tertiary carbons. And the tertiary carbons just like to hold positive charge a little better than the secondary carbons over here.